Hello and welcome to Plunge into Science. Tonight, there is nothing for you to do, nothing to solve. Simply find a comfortable position. Let your body feel heavy and relaxed. Allow your breathing to become slow and deep and rhythmic. Tonight, we are not just going to learn. We are going to wonder. We are going to let our minds drift on the gentle currents of cosmology and theoretical physics. We are embarking on a journey not outward to the stars, but inward, into the very fabric of reality itself. We are going to explore the unseen, the unfelt, the higher dimensions that may be hiding all around us, intertwined with our every moment. Let my voice be a guide, a soft murmur in the quiet of your room, as you allow your consciousness to expand and explore these beautiful, abstract realms. There is no need to hold on to any single thought. If you drift off, that is perfectly fine. The ideas will find their way. Let's begin our journey into the unseen reality. Section 1. The shadow on the wall. Let us begin with a simple thought. A comfortable thought. Imagine a single point, a dot. It has no size, no width, no depth. It is pure location, a mathematical idea. In the language of geometry, this is a dimension of zero. A zero-dimensional universe. It is a lonely existence, is it not? A single point with nowhere to go. There is no concept of distance or direction. It simply is. Feel the simplicity of that, the utter stillness. Now let us give this point a friend. Let's place another point somewhere else. And now let us connect them. The line that forms between them is a new reality. It is a one-dimensional universe. For a creature living on this line, there are only two directions, forward and backward. There is no left or right, no up or down. Everything in its universe exists along this single, infinite path. Imagine yourself as this one-dimensional being. Your entire perception of the world is a sequence of points along a line. You could pass another being, but you could never go around them. Your universe is profoundly simple, yet it is a universe nonetheless. It has one degree of freedom, one dimension, length. Can you feel the constraints of that reality? The elegant simplicity of moving only forward or back. But what if a light were to shine on this line world from somewhere else? A place this creature cannot comprehend. And what if a two-dimensional object, a square, were to pass through this light? The creature on the line would not see a square. How could it? It has no concept of width. It would only see the shadow of the square's edge. First, a single point would appear in its reality. Then, that point would stretch into a line segment, which would remain for a time, and then it would shrink back to a point and vanish. To the one-dimensional being, this would be a mysterious event, a moment of existence that appeared from nothing and returned to nothing. It would have no way of knowing that it was merely witnessing a slice, a cross-section, of a higher, richer reality. This is the first key to understanding higher dimensions. Our perception is limited by the dimensions we inhabit. What we experience may only be a shadow, a slice of a much larger, more complex truth. Now let us expand our thinking. Let's take our line and move it in a direction it has never been before. Let's drag it sideways into a new second dimension. As we do, it paints a surface, plane, a square. This is a two-dimensional world, a flat land. A being in this world has length and now width. It can move forward and backward, and now also left and right. Its world is infinitely more complex and rich. It can draw shapes, navigate around obstacles, and perceive a world of surfaces. Think of a character on a page in a book, or a figure on a screen. Their entire reality is that flat plane. Imagine you are this flatlander. Your name is A Square. You live in a world of polygons. Your house is a pentagon. You see your friends as line segments of varying lengths. You can't see inside them because that would require looking down from above, a concept that is utterly alien to you. The very word up has no meaning. Your world is complete and consistent. You have no reason to suspect anything else exists. But then one day, a three-dimensional object passes through your world, a sphere. What would you, A Square, perceive? You would not see a sphere. You would first see a single point appear out of nowhere. Then that point would grow into a small circle. The circle would expand to its maximum size, the equator of the sphere. And then it would begin to shrink, smaller and smaller, until it became a point again, and then it would vanish. For you, the Flatlander, this would be a miracle, a magical, terrifying event, an object that can change its size and shape at will, appearing from nothing and disappearing into nothing. A voice might even speak to you from all around, because the sound waves from the third dimension would arrive at you from every direction at once. The three-dimensional being could see the inside of your locked houses, the contents of your body. It would seem like a god. But it is not magic. It is simply a matter of perspective, a matter of one more dimension. And so, we must ask ourselves the first gentle question of the night. As you lie here in your comfortable three-dimensional world, are we the Flatlanders? Are the strange, inexplicable phenomena of our universe, the weirdness of quantum mechanics, the mystery of dark energy, are these just shadows? Are they just the cross-sections of four-dimensional, or five-dimensional, or even 10-dimensional objects passing through our perception? What would a hypersphere look like as it passed through our room right now? Would it be a sphere that appears from a single point, grows to a maximum size, and then shrinks and vanishes? Perhaps the universe is constantly being visited by these higher dimensional realities, but we, with our three-dimensional minds, only interpret the strange shadows they cast. Let this thought wash over you. The idea that what you perceive as reality is just a slice of a much grander, more magnificent whole. Relax into that possibility, that you are witnessing the beautiful, fleeting shadow of a higher truth. Section 2. Building our world and beyond. Let your mind settle on that image of the Flatlander, baffled by the sphere. Let's stay with that feeling of wonder. Now we will build upon it, step by step, dimension by dimension, not with complex mathematics, but with the quiet power of our imagination. We are constructing a ladder of dimensions, and we will climb it together in our minds. We began with a point, a zero-dimensional concept. No length, no width, no height, a single address in the cosmos. Let this point represent the beginning of all structure. It is pure potential. Now breathe in, and as you breathe out, imagine pulling that point. Stretch it out in a single direction. You have created a line, one dimension, length. This line contains an infinite number of points, all lined up in a perfect row. A creature living here, as we explored, knows only back and forth. Its entire sensory experience is linear. The universe is a thread. All of history is a sequence on that thread. There is a beautiful, stark simplicity to it, kind of geometric purity. Can you imagine the peace of such a simple existence? No complex choices of direction, just the path ahead and the path behind. Now take a slow, deep breath again, and as you exhale, imagine taking that entire line and dragging it at a right angle to itself, into a new, unseen direction. You are sweeping out a square, a plane, two dimensions, length and width. This is the world of Flatland. Suddenly the universe has area. It has surfaces. The possibilities have exploded. You can create not just lines, but circles, triangles, complex coastlines. An entire world of art and geometry can exist on this surface. The two-dimensional being has so much more freedom than its one-dimensional ancestor. It can explore a vast landscape, a map of infinite possibility, but it is still constrained. It can never experience the concept of over or under. It can be trapped within a circle drawn around it with no escape, for the idea of simply stepping over the line is inconceivable. This is our world. Or at least it's getting closer. We live on the surface of a sphere in a way, but we perceive a third dimension. So let's take the next step on our ladder. Breathe in once more, feeling your chest rise and fall. As you let the breath go, visualize our two-dimensional plane. Now lift it. Lift it up. Up is a direction that the Flatlander could not point to, a word without meaning. But for us it is natural. As we lift this plane, we are dragging it through a third dimension. A square becomes a cube. A circle becomes a sphere. A flat world gains depth. And here we are. This is the world you know, a three-dimensional universe. You have length, width, and now height. You can move forward and backward, left and right, and up and down. 3 axes, 3 degrees of freedom. This is what allows for the rich complexity of our existence. It allows for a knot to be tied. It allows for a heart to be enclosed within a chest. It allows for you to be lying here in your bed, with a space above you and a floor below you. Everything you have ever touched, seen, or held is a three-dimensional object. Your brain, the very tool you are using to ponder these ideas, is a three-dimensional structure of immense complexity. We feel so at home here, in our three dimensions. It feels complete. It feels like all there is. But remember our Flatlander. His two-dimensional world felt complete to him too. He had no reason, no evidence in his daily life to suggest the existence of up. So we must ask the question with genuine, gentle curiosity. Why should the ladder stop here? Why should 3 be the final number for spatial dimensions? The process we used to build our world was consistent. A point dragged makes a line dragged makes a square dragged makes a cube. What happens if we perform that operation one more time? What happens if we take our entire three-dimensional world, our cube, and drag it in a new direction, a fourth spatial direction, at a right angle to length, width, and height? Try to picture it. It's impossible for our minds to truly visualize, just as up was impossible for the Flatlander. But we can think about it logically. We can explore its properties through analogy. This new direction is not left or right, not forward or back, not up or down. Let's call it Ana and Keta, the fourth dimensional equivalent of up and down. If we drag our cube in the Ana direction, what shape does it create? It creates a four-dimensional hypercube, a tesseract. You may have seen artistic representations of it. A small cube floating inside a larger cube, their corners connected. But that is just a shadow. It is the three-dimensional shadow of a four-dimensional object, just as the flat, two-dimensional shadow of a cube on the wall does not capture its true solid nature. A true tesseract would have 8 cubes as its faces, just as a cube has 6 squares for its faces, and a square has 4 lines for its edges. To a being who could perceive the fourth dimension, our solid, three-dimensional world would be as open and transparent as a drawing on a piece of paper is to us. A four-dimensional doctor could perform surgery on you without ever cutting your skin. They could simply reach around your three-dimensional body, through the fourth dimension, and remove a tumor, just as you could lift a dot out of a circle drawn on paper without breaking the line. A four-dimensional being could see every room in your house at once, the inside and the outside simultaneously. They could see your past, present, and future laid out like the pages of a book. Let your mind float with this idea. Don't struggle to see it. Just feel the edges of the concept, the profound implication that our perception of solidity, of inside and outside, might be an illusion, an artifact of our limited three-dimensional perspective. What if the universe is not just the 3 dimensions we see, but a vast hyperdimensional space? What if we are living inside a complex 4-dimensional structure, but we are only capable of ever seeing one 3-dimensional slice of it at a time? Is it possible that the feeling of time passing, of moving from one moment to the next, is actually our 3-dimensional consciousness moving through a static, 4-dimensional reality? Let that thought settle. The idea that all of time might exist at once and we are just experiencing it slice by slice. Relax into the mystery, the grand, beautiful, and unseen architecture of a reality just beyond our senses. Section 3. Time as a dimension, the block universe. We have just touched upon a profound idea, the idea of time. Let's linger here for a while. In our quest for a fourth dimension, we have been thinking spatially, of a direction like up or down. But what if the fourth dimension is not somewhere else we can point to, but something we are traveling through at every moment of our lives? What if the fourth dimension is time? This is not just a philosophical fancy. This is a cornerstone of modern physics, born from the incredible mind of Albert Einstein. He wove together our 3 familiar spatial dimensions with the dimension of time into a single unified fabric, space-time. Think of it not as a stage upon which events happen, but as the stage itself, a dynamic entity that can be bent, warped, and stretched. Let's go back to our ladder of dimensions for a moment. A point has a location in space, but if it only exists for an instant, it's just a fleeting ghost. To truly exist, it must persist, must have a location in time as well. A point that exists for a duration traces a line in space-time. A one-dimensional line, existing through time, traces a two-dimensional plane in space-time. And our three-dimensional world, your room, your body, as it persists from one moment to the next, is tracing out a path through this four-dimensional space-time. You are not just a three-dimensional being. You are a four-dimensional event, a world line stretching from your birth to your death. This leads to a startling and deeply calming concept known as the block universe. Imagine time is not a flowing river, but a frozen landscape. Imagine the entire history of the universe, from the Big Bang to its ultimate end, exists all at once as a single, static, four-dimensional block of space-time. Every moment that has ever been and every moment that ever will be is already there. It is permanent. The past is not gone. The future is not unwritten. It all coexists. Our consciousness, our perception simply moves through this block. Our feeling of the present is like a spotlight illuminating one three-dimensional slice of this block at a time. The past is the slices we have already illuminated, and the future is the collection of slices we have yet to encounter. But from a hypothetical four-dimensional perspective, looking down upon this block, there is no flow. Your birth this moment right now as you listen to my voice, and your final moments, are all just different points along your world line within this static block. What does this mean for us as we lie here on the edge of sleep? It means that every beautiful moment you have ever experienced is not lost. It is not vanished into a forgotten past. It is a permanent feature of the geometry of space-time, that cherished memory from childhood, a moment of pure joy, a loving embrace. It is still there. It exists as surely as the city of London exists. You just aren't there right now. Your spotlight of consciousness has moved on, but the landscape remains. There is a kind of peace in this, isn't there? A sense of permanence. Nothing is truly lost. Let's think about what this means for cause and effect. In the block universe, cause does not create effect in a dynamic way. Instead, they are just different coordinates in the block that are related by the laws of physics. It's like saying the number 4 on a ruler doesn't cause the number 5 to exist. They are just fixed positions, and the relationship between them is that 5 comes after 4. The Big Bang doesn't cause the present moment in a flowing temporal sense. Rather, the state of the universe at the time of the Big Bang and the state of the universe now are simply two different layers of this space-time block, and their configurations are linked by the equations of physics that govern the entire structure. This can feel deterministic, as if we have no free will. But perhaps free will is also part of this structure. Perhaps your choices, your decisions, are the very process by which your unique world line is patterned into the block. Your consciousness is not a passive passenger on a train. It is the architect drawing the tracks as it goes, but the entire drawing, once complete, exists as a whole. So, as you drift deeper, let your mind play with this idea. The block universe. See your life as a long, beautiful ribbon woven into the fabric of space-time. Every thread, every color, every texture is a moment of your existence. Nothing is frayed. Nothing is lost. The joys are still there. The sorrows are still there. The learning, the growth, the love, it is all part of a permanent, magnificent tapestry. From a higher dimensional viewpoint, your life is a complete and perfect work of art. There is no need to worry about the future or regret the past. It is all part of one unified existing whole. Can you feel the gentle release in that thought? The permission to simply be right here, in this slice of space-time, knowing it is one beautiful part of an eternal, unchanging whole. Let go of the feeling of time's urgent rush. In the block universe, there is no rush. There is only isness. Allow yourself to float in that peaceful, timeless, four-dimensional ocean. Section 4. The tesseract and the shadow of a higher shape. Let's gently return to the idea of a fourth spatial dimension. We have explored time as the fourth dimension, a concept grounded in our known physics. But now let us be more speculative. Let us allow our minds to play in the realms of pure geometry, a place where we can build worlds with thought alone. This is a peaceful exercise. There is no need for strain. We are just observing, just wondering. We spoke of the tesseract, the four-dimensional hypercube. Let's spend some more time with this fascinating, unseeable object. Let's try to understand it not by sight, but by analogy, by feeling its shape through the logic of its construction. Remember our process. A point moved creates a line. A line is bounded by 2 points. A line moved at a right angle creates a square. A square is bounded by 4 lines. A square moved at a right angle creates a cube. A cube is bounded by 6 squares. Now feel the rhythm of that progression. 0, 1, 2, 3 dimensions. And so, a cube, our three-dimensional object when moved at a right angle to itself through the fourth dimension, creates a tesseract. And a tesseract following the pattern must be bounded by 8 cubes. Imagine holding a wireframe cube in your hands. You can see its 6 square faces, its 12 edges, its 8 corners. Now, imagine a 4-dimensional being holding a wireframe tesseract. They would see its 8 cubical faces, its 24 square ridges, its 32 edges, and its 16 vertices. It is a structure of sublime complexity. We cannot see it directly, but we can see its shadow. Just as a 3-dimensional cube can cast a 2-dimensional shadow on the wall, a 4-dimensional tesseract can cast a 3-dimensional shadow into our world. The most common depiction of this shadow is the one we mentioned. A smaller cube nested inside a larger cube, with their corresponding corners connected. Let's explore this shadow. As you picture it in your mind's eye, notice that the cubes in the shadow are distorted. The inner cube is smaller, and the outer cube is larger. The connecting faces are trapezoidal, not square. This is because it is a projection, a perspective view. Just like when you draw a cube on a flat piece of paper, the lines representing depth have to be drawn at an angle, and the square at the back looks smaller than the square at the front. The shadow is not the object itself. Now imagine this tesseract is rotating in the 4th dimension. What would its 3-dimensional shadow do? It would be a mesmerizing, bewildering dance. The inner cube would appear to grow larger and emerge to become the outer cube, while the outer cube would shrink and fold inward to become the inner one. The cubical faces would seem to pass through one another, turning themselves inside out. It would look like a violation of all the laws of space as we know them. But it is not. It is simply the 3-dimensional projection of a perfectly normal, rigid rotation of a 4-dimensional object. Can you let your mind gently hold that image? The constant flowing transformation of a shape that seems impossible. It is a visual representation of how a higher dimensional reality might appear to our limited senses. Paradoxical, magical, yet governed by a deeper, unseen logic. Let's try another way to comprehend it. Think of unfolding a box. You can take a 3-dimensional cube and unfold its 6 square faces to lie flat on a 2-dimensional surface. The result is a cross-shaped pattern. You can see all 6 squares at once in this unfolded 2-dimensional form. In the same way, you could unfold a 4-dimensional tesseract into our 3-dimensional space. The result would be a shape made of 8 cubes, connected by their faces, arranged in a 3-dimensional cross. You could, in theory, walk around this structure and touch all 8 of the cubes that form the boundary of a single tesseract. What is the purpose of this mental exercise? It is to stretch our imagination, to gently nudge the boundaries of what we consider real. Our brains evolved to navigate a 3-dimensional world, to hunt for food and avoid predators. We are exquisitely adapted to this reality, but the universe may not be limited to what our evolutionary history has prepared us for. These higher dimensions, if they exist, are a reality that lies beyond our biological hardware. So we must ask ourselves, what other shadows are we seeing? When particle physicists at the Large Hadron Collider smash particles together and see debris that seems to vanish, could it be that some of the energy and momentum has been thrown out of our 3 dimensions into a 4th, and we are just seeing the shadow of its departure? When we observe the force of gravity, which is so mysteriously and profoundly weaker than the other forces of nature, like electromagnetism, could it be that gravity is not truly a 3-dimensional force? Could it be a 4 or 5-dimensional force, and we only experience a tiny fraction of its true strength because most of it is leaking out into these other dimensions? Don't worry about finding the answers to these questions. The goal is not to solve physics tonight. The goal is to wonder, to feel the vastness of the possibilities, to replace the certainty of our everyday perception with a soft, gentle, and peaceful sense of profound mystery. The universe may be so much grander, so much more intricate and beautiful than we can currently perceive. And that is a comforting thought. It means there is always more to discover, more wonder to be found. Allow your mind to relax into this state of open curiosity. Let the image of the rotating tesseract be a symbol of this hidden reality, a cosmic dance happening just out of sight. Let it lull you into a state of deep and restful peace. Section 5. Kaluza-Klein and the Curled-Up Dimension. Our journey into the unseen has so far been one of grand, expansive dimensions. A fourth dimension stretching out to infinity, just like our own. But what if a higher dimension was not vast and sprawling? What if it was incredibly, unimaginably small? So small that it is curled up, hidden within every single point in our space. Let us explore this delicate, beautiful idea, a whisper of a dimension hiding in plain sight. This is not a new idea. It has a history, a story. Let's travel back in our minds to the early 20th century, a time of revolutionary physics. Einstein had just published his theory of general relativity, describing gravity not as a force, but as the curvature of four-dimensional space-time. It was a masterpiece, a symphony of geometry. But it only described one force, gravity. What about the other known force at the time, electromagnetism? The force that governs light, electricity, and magnetism. Could it too be described by the geometry of space-time? In 1919, a brilliant but little-known mathematician named Theodore Kaluza sent a letter to Einstein. In it, he proposed something audacious. He suggested that if the universe had not four but five dimensions, four of space and one of time, then something remarkable happened. When he wrote out the equations for general relativity in 5 dimensions, the standard 4-dimensional equations for gravity fell out naturally. But there was something left over, an extra set of equations. And when he examined them, he found, to his astonishment, that they were precisely the well-known equations of electromagnetism. It was a miracle of mathematics. By adding one simple, extra spatial dimension, Kaluza had seemingly unified the two greatest forces known to science into a single, elegant theory. Gravity was the curvature of the familiar dimensions. Electromagnetism was the curvature of the hidden 5th dimension. But this raised an obvious and profound question. If this 5th dimension exists, where is it? We can move up and down, left and right, forward and back. We see no evidence of a 4th spatial direction to move in. How could such a dimension be hidden from us? This is where another physicist, Oscar Klein, made a crucial contribution a few years later. He proposed that the 5th dimension is not large and extended like our own. Instead, it is curled up into a tiny, tiny circle. Imagine a garden hose. From a great distance, it looks like a one-dimensional line. You can only perceive its length. But if you look at it very closely, you see that at every point along the line, there is a second dimension, a tiny circle you can travel around. The circumference of the hose. Klein suggested that the 5th dimension is like this. At every single point in our 3-dimensional space, there exists a tiny subatomic circle of a 4th spatial dimension. It is curled up so tightly, on a scale far, far smaller than an atom, that we cannot perceive it. We are like the beings viewing the garden hose from afar. We see the long, extended dimensions of our universe, but we are completely unaware of the tiny, curled-up dimension that exists at every point within it. A particle like an electron could not only move through our 3 dimensions, but could also travel around this tiny 5th-dimensional circle. And according to the theory, the momentum of the particle as it travels around this circle would manifest in our dimensions as its electric charge. A particle moving one way around the circle might be an electron with a negative charge. A particle moving the other way might be a positron with a positive charge, and a particle that is not moving at all in that 5th dimension would be neutral, like a photon. Let this beautiful idea sink in. The fundamental property of electric charge, which seems so arbitrary, could be nothing more than movement in a hidden circular dimension. The universe, at its most fundamental level, is a dance of pure geometry. So why don't we just slip into this 5th dimension? Because it is so fantastically small, the energy required to move into it would be colossal, far beyond anything we can generate. For all practical purposes, we are locked into our large, extended dimensions. But the dimension is still there. It is with you right now. At every point inside your body, at every point in the air you are breathing, in the bed you are resting on, there is a tiny, hidden loop of another dimension. Does this thought feel strange, or does it feel right? In a way, it makes the universe feel more intricate, more jewel-like. It suggests that reality has a hidden microscopic texture, secret geometry woven into the fabric of everything. It's like discovering that the threads of a grand tapestry are themselves woven from even finer, more complex threads. Kaluza-Klein theory, in its original form, ultimately did not work out perfectly. It made predictions that didn't match observations, and it couldn't incorporate the other forces of nature that were later discovered. But the core idea, the concept of extra dimensions being small and curled up, was so powerful and so elegant that it never went away. It planted a seed that would blossom decades later into one of the most ambitious ideas in all of science: string theory. So, as you drift deeper and deeper into relaxation, imagine this hidden world. Picture every point of space not as a simple dot, but as the gateway to a tiny coiled-up circle of another reality, a secret pathway that exists everywhere at once. The universe is not just what you see, it is what you see, plus a hidden filigree of unimaginable complexity and beauty, woven into the very points of existence. Let your consciousness be still, and feel the quiet hum of this unseen, curled-up reality, all around you and within you. Section 6. String Theory and the Symphony of Reality. We have journeyed from the idea of grand, infinite dimensions to the concept of a single, tiny, curled-up one. Now our path takes us to a place where these ideas merge and expand into a breathtaking vision of reality. Let's gently explore the world of string theory. Do not worry about the mathematics. We are here to appreciate the poetry of the idea, the music of it. For much of the 20th century, physics had two magnificent theories: general relativity, which described the large-scale universe of planets, stars, and galaxies, with the beautiful geometry of space-time, and quantum mechanics, which described the small-scale universe of atoms and particles with incredible accuracy, but in a world of strange probabilities and uncertainties. The problem was these two theories did not get along. They spoke different languages. When you tried to use them together, in extreme situations like the center of a black hole or the moment of the Big Bang, they broke down, giving nonsensical, infinite answers. The greatest challenge in physics has been to find a single, unified theory, a theory of everything, that could gracefully describe both the grand and the microscopic. String theory is, to date, our most promising candidate for such a theory, and its central idea is wonderfully simple and profoundly revolutionary. It suggests that if you could zoom in on a fundamental particle, like an electron or a quark, you would not find a zero-dimensional point. You would not find a tiny solid ball. Instead, you would find a minuscule, one-dimensional loop of vibrating energy, a tiny, vibrating filament. String, that is the fundamental ingredient of the universe. Not particles, but strings. And just like the string on a violin or a guitar, these cosmic strings can vibrate in different ways. They can have different resonant patterns, different frequencies. And here is the beautiful part. Each different mode of vibration corresponds to a different fundamental particle. In this view, the universe is a grand cosmic symphony. An electron is a string vibrating in one way. A photon, the particle of light, is a string vibrating in another way. A quark is a string vibrating in yet another. All the particles we see, all the rich diversity of matter and energy that makes up our world, are nothing more than the different notes being played on these fundamental strings. The properties of a particle, like its mass or its charge, are determined by the way its string is vibrating. A more energetic vibration, a higher frequency, would be perceived by us as a more massive particle. It is an idea of breathtaking elegance. It unifies all of matter and all of force into a single concept, the music of these tiny, dancing strings. But for this beautiful idea to work, it comes with a startling requirement. The mathematics of string theory is only consistent if the universe does not have just 3 spatial dimensions. It requires that the universe has 9 or 10 spatial dimensions, plus 1 of time. 10 or 11 dimensions in total. Suddenly, the extra dimensions we have been exploring are not just a curious possibility. They are a mathematical necessity for this theory to be true. Without them, the equations of string theory fall apart. So where are they? Just as Klein proposed for his 5th dimension, string theory suggests that these extra 6 or 7 dimensions are curled up. They are compacted, hidden from our large-scale perception. But they are not just simple circles. They are thought to be curled up into incredibly complex six-dimensional shapes. These shapes are known as Calabi-Yau manifolds, and we will explore their beauty in our next section. For now, just stay with this idea of a vibrating reality. Imagine that the fabric of space, at its tiniest level, is teeming with these extra dimensions, all curled up in an intricate, multi-dimensional origami. And within this complex dimensional space, these tiny strings are vibrating. The symphony they are playing is what creates the universe you experience. Think about what this means. The laws of physics, the way particles interact, the very nature of our reality, is determined by the geometry of these hidden dimensions. If these extra dimensions were curled up in a different shape, the strings would vibrate differently. The notes they could play would change. The particles that exist would be different. The forces of nature would have different strengths. The universe would be a completely different place. So, the fundamental questions of physics. Why does the electron have the mass it does? And why is gravity so weak? Might all be answered by a single, deeper question. What is the shape of the hidden dimensions? Our universe is what it is because of this secret subatomic geometry. Let your mind rest on this image. The universe is a musical instrument of immense dimensionality. All of existence, from the light hitting your closed eyelids to the atoms that make up your body, is a harmony played on vibrating strings. The rules of this harmony are written in the shape of tiny, curled-up dimensions you can never see. Can you feel the shift in perspective? The world is no longer made of hard, solid bits of matter. It is made of music. It is a vibrational, resonant reality. This is a deeply peaceful and unifying thought. Everything is connected. Everything is made of the same fundamental stuff, these vibrating strings. You, the stars, the air, and the room are all different songs played on the same cosmic instrument. As you sink into sleep, let yourself become part of this symphony. Feel the gentle rhythmic vibration of existence, and let it carry you into a deep and restorative rest. Section 7. M-Theory, Brains. And the multiverse, we've imagined our universe as a symphony of strings vibrating in 10 dimensions. This was the picture from string theory in the 1980s and 90s. But as physicists delved deeper, they found something strange. There wasn't just one version of string theory. There were five different consistent mathematical models, all describing a universe of strings and extra dimensions. This was a problem. If string theory was to be a theory of everything, there should only be one everything. Then, in the mid-1990s, a new revolution occurred. A physicist named Edward Witten proposed a breathtaking new perspective. He suggested that these 5 different string theories were not competing theories at all. Instead, they were like 5 different windows looking into the same larger house. They were 5 different approximations of a single, deeper, more mysterious theory, a theory that lives in 11 dimensions. He called it M-Theory. The M is famously ambiguous. It could stand for mystery, magic, or mother of all theories. But many believe it stands for membrane, because in M-Theory, strings are not the only fundamental objects. The theory introduces higher dimensional objects called brains. The word brain comes from the word membrane. Think of it this way. A 0-dimensional object is a point. A 1-dimensional object is a string. 2-dimensional object is a membrane, or a 2-brain. You can have 3 brains, 4 brains, and so on, all the way up to 9 brains. In M-Theory, the universe is filled not just with vibrating strings, but with these vast, undulating brains of various dimensions. This leads to one of the most mind-expanding ideas in all of science. What if our entire universe is just one of these brains? Imagine our universe, all of the 3 spatial dimensions we know, all the galaxies, stars, and planets, is a giant 3-brain. We are living on the surface of this 3-dimensional membrane. And this brain is floating in a much larger, higher dimensional space, a space often called the bulk. This bulk has more dimensions than our own, perhaps 10 or 11 in total. This is a radical shift in perspective. Our universe might not be all there is. It could be just one slice, one surface in a much vaster hyperspace. Now think about the strings. In this picture, some strings might have their ends tied down to our 3-brain. These are called open strings. The vibrations on these strings would create the particles and forces that are stuck in our universe, like electrons, quarks, and the forces of electromagnetism, and the nuclear forces. This would explain why we can't just float off into the extra dimensions. Most of reality as we know it is confined to our brain. We are, in a sense, flatlanders on a three-dimensional sheet of paper. But what about gravity? This is where the idea gets truly fascinating. In M-theory, the particle that carries the force of gravity, the graviton, is represented by a closed loop of string. And a closed loop of string is not tied down to anything. It is free to travel anywhere. This means that gravitons are not confined to our three-brain. They can leak out from our universe and travel through the higher dimensional bulk. This provides a beautiful and elegant explanation for why gravity is so much weaker than the other forces. It's not that gravity is intrinsically weak. It's that its strength is being diluted. It is spreading out across all the extra dimensions. We only feel the small fraction of its force that happens to stick to our brain. The other forces feel strong because they are concentrated, trapped entirely within our three dimensions. And if our universe is one brain floating in a higher dimensional bulk, could there be other brains? M-theory allows for this possibility. There could be other universes, other three brains floating parallel to our own, in the vastness of the bulk. They could be just a millimeter away from us, but in a direction we cannot point to, in a dimension we cannot access. Parallel universe, right here, right now, completely invisible and inaccessible to us. Is it possible for these brain worlds to interact? Perhaps. The theory suggests that only gravity, carried by those closed loops of string, could pass from one brain to another. If a massive star exploded in a parallel universe, we wouldn't see the light, but we might feel a faint gravitational ripple. This has led some scientists to speculate that the mysterious dark matter and dark energy that make up most of our cosmos could be the gravitational influence of a nearby parallel universe, its shadow cast upon our own. Let your mind drift on this cosmic ocean of possibility. Our universe, which feels so vast and all-encompassing, might just be one page in an infinite book. A single bubble in a sea of cosmic foam, a single membrane floating in an 11-dimensional hyperspace. This idea is humbling, is it not? It decentralizes us, not just from our planet or our galaxy, but from our entire universe. But it is also deeply awe-inspiring. It suggests that reality is infinitely richer, larger, and more mysterious than we ever imagined. The cosmos may be teeming with other worlds, other laws of physics, other forms of existence, all playing out their stories on separate brains, just a whisper away in a higher dimension. As you lie here, feel the quiet solitude of our brain, and then imagine the presence of these others, not as a frightening thought, but as a comforting one, a sense of a larger cosmic family, all part of the same grand 11-dimensional structure of M-theory. The universe is not empty. It is just very, very large, in ways we are only beginning to comprehend. Rest in that vastness. Rest in that profound and beautiful mystery. Section 8. The Shape of Hidden Worlds. Calabi-Yau Manifolds. We have spoken of the extra dimensions required by string theory and M-theory. We have accepted for this journey that they are there, but they are small and curled up. But we have not yet asked a crucial question. What do they look like? What is their shape? If we could shrink down to the quantum level and peer into these hidden spaces, what geometry would we find? The answer, according to the theory, is not a simple circle or a sphere. The shape of these hidden six-dimensional spaces must be very specific. They must be what mathematicians call a Calabi-Yau manifold. Let the name wash over you. Calabi-Yau. It sounds complex, and it is. These are some of the most intricate and beautiful structures in all of mathematics. Trying to visualize one is even more difficult than picturing a tesseract, because they have 6 dimensions, and they are curved in complex ways. But we can approach their nature through feeling and metaphor. Imagine the most intricate piece of origami you have ever seen. A delicate paper sculpture with countless folds, tucks, and hidden hollows. Now imagine that sculpture is not made of paper, but of the fabric of space itself. Imagine it has not 2 or 3 dimensions, but 6. And imagine that it is so small that trillions upon trillions of them could fit on the head of a pin. This begins to give you a sense of a Calabi-Yau manifold. At every single point in our familiar 3-dimensional space, One of these complex, six-dimensional shapes is thought to exist. They are the hidden architecture of reality, the secret internal geometry of space. Why this particular shape? It comes from the requirements of the theory. String theory needs to reproduce the physics we see in our world. It needs to have features like supersymmetry, a proposed symmetry between particles of matter and particles of force, to be mathematically consistent. And it turns out that Calabi-Yau manifolds are the shapes that have the right properties to allow for this. They are, in a sense, the vacuum cleaners of dimensions. They can take a 10-dimensional theory and make it look like a 4-dimensional one in a way that works. But there is a catch. A big one. Mathematicians have discovered that there is not just one possible shape for a Calabi-Yau manifold. There are thousands, perhaps millions, perhaps a number so vast it defies imagination. Some estimates go as high as 10 to the power of 500. Each one of these different possible shapes for the extra dimensions is a valid mathematical solution to the equations of string theory. And as we discussed earlier, the shape of the extra dimensions determines everything. The way the strings can vibrate depends on the geometry of the Calabi-Yau space they are vibrating within. The precise shape, the number of holes it has, the way it twists and curves, determines the notes in the cosmic symphony. This means that each different Calabi-Yau manifold would create a universe with different physical laws. One shape might create a universe with particles like ours, electrons, quarks, photons. Another, slightly different shape might create a universe with completely different particles and forces. Another might create a universe that collapses back on itself in an instant, or one that expands so fast that no stars or galaxies could ever form. This has led to the idea of the string theory landscape. Imagine a vast landscape of possibilities. Each point in this landscape is a different Calabi-Yau manifold, a different way for the extra dimensions to be curled up, and each point corresponds to a different possible universe, with its own unique set of physical laws. So where are we in this landscape? The theory suggests that in the fiery chaos of the Big Bang, the universe could have been formed with any one of these shapes. And perhaps the multiverse is real, and every possible shape exists somewhere, in some other bubble universe. Our universe just happens to be one where the dimensions curled up into a Calabi-Yau shape that was stable. And that allowed for the right kind of string vibrations to produce the laws of physics that eventually led to stars. Planets and us, we live in a hospitable valley in this immense landscape of possibilities. We exist because the hidden geometry of our space is just right. Let yourself contemplate the sheer beauty of this idea. The laws of nature are not arbitrary random numbers. They are a consequence of a hidden six-dimensional geometry. The reason an electron has the mass it does is related to the subtle curvature of a Calabi-Yau manifold that exists at every point in space. The universe is a product of an unseen, sublime, and incredibly complex mathematical art. You do not need to see this shape. Just feel its presence. Feel the intricate hidden complexity that underpins the simple reality you perceive. At this very moment, in the space between the atoms of your body, there is a geometry of unimaginable elegance. It is humming with the potential of all the other universes that could have been. It is the reason you are here. The universe is not just grand on the largest scales, but also on the smallest. It is a palace of hidden rooms, of secret corridors, of jewel-like geometries that dictate the nature of being. As you relax, let go of the world you see, and feel the presence of this hidden, beautiful, six-dimensional flower blooming in the heart of every point of space. Let its quiet complexity be a mantra that guides you into a deep, profound, and peaceful sleep. Section 9. Faint Echoes and Cosmic Clues. Searching for Dimensions. This journey has taken us deep into the realm of theory, of what if. It is a beautiful and peaceful place for the mind to wander. But science eventually must return to the world of evidence, of observation. So as we drift in this calm, pre-sleep state, let's gently ask the question, how could we ever know? How could we find proof of these hidden dimensions? Are they destined to forever remain in the realm of mathematics and imagination? Or could we one day find a faint echo of their existence in our world? The search for higher dimensions is one of the most exciting frontiers of modern physics. Scientists are not just thinking about these ideas. They are actively looking for clues. The search takes place in two main arenas: the realm of the very, very small, and the realm of the very, very large. Let's first visit the world of the small, at places like the Large Hadron Collider, LHC, in Switzerland. The LHC is the most powerful particle accelerator ever built. It smashes protons together at nearly the speed of light, recreating for a fleeting instant the incredible energies of the early universe. The goal is to see what new particles and phenomena emerge from these collisions. How could this reveal extra dimensions? Remember the idea from M-theory, that gravity might be able to travel into the extra dimensions, while other forces cannot. Some variations of this theory suggest that these extra dimensions might not be as small as the minuscule Planck length we've been imagining. They could be large extra dimensions, perhaps as large as a millimeter. We don't notice them because only gravity can access them. If this is true, then in a high-energy collision at the LHC, it might be possible to create a particle of gravity, a graviton that gets kicked off our brain. It would be ejected from our three dimensions and fly off into the higher dimensional bulk. From our perspective, it would look like energy has vanished from the collision. The detectors would see less energy coming out than went in. This missing energy would be a tantalizing signature, a clue that something has escaped our known dimensions. Scientists are meticulously sifting through trillions of collisions, looking for events that show this specific pattern. So far, they have found nothing conclusive, but the search continues with every new experiment. Another possibility at the LHC is the creation of microscopic black holes. If there are large extra dimensions, gravity would become much stronger at very short distances. It might become strong enough that two particles colliding with enough energy could actually get close enough to form a tiny, fleeting black hole. This micro black hole would exist for a fraction of a second before evaporating in a shower of particles. Such an event would be a spectacular and unmistakable sign of new physics and new dimensions. Now, let's turn our gaze outward, to the vastness of the cosmos. Could there be clues written in the sky? Perhaps. The earliest light in the universe, the cosmic microwave background radiation, is a baby picture of the cosmos just 380,000 years after the Big Bang. Scientists study the tiny temperature fluctuations in this light with incredible precision. If there were extra dimensions present in the early universe, they might have left a subtle imprint on this radiation, a specific pattern in the hot and cold spots that we could one day detect. And what about gravitational waves? These ripples in the fabric of space-time, now being detected by observatories like LIGO and Virgo, are a new way to listen to the universe. Could a gravitational wave from a black hole merger show strange properties? Could it be carrying information about extra dimensions it has traveled through? Some theories predict that extra dimensions would cause gravity waves to have extra polarizations, extra modes of vibration, like a sound with a strange, otherworldly timbre. Detecting such a signal would be a Nobel Prize-winning discovery, a clear sign that gravity experiences more than the three dimensions we do. It is a quiet, patient search. It is like listening for the faintest of whispers in a hurricane. The signals, if they exist, are likely to be incredibly subtle, but the possibility keeps scientists looking. What does this mean for you as you lie here relaxing? It means that the universe is still full of profound secrets. The answers are not all in. We are still explorers, mapping an unknown territory. The very fabric of reality is an open question, and that is a wonderful thing. It fills the cosmos with a sense of potential, of imminent discovery. Think of the scientists sifting through data and the astronomers pointing their telescopes to the sky. They are all, in their own way, searching for the unseen reality we have been exploring tonight. They are looking for the shadow of the tesseract, for the echo of the vibrating string, for the gravitational ripple from another brain. You don't need to wait for their results. Tonight in your mind you can find these dimensions. You can feel their possibility. The universe doesn't have to prove itself to you for you to appreciate its potential beauty. The ideas themselves have a kind of power, a power to expand your sense of what is real, to make the world feel larger, more mysterious and more magical. So let your mind be at peace. The search is underway, The cosmos is slowly revealing its secrets, and you can rest, knowing you are part of a universe that is still, in its deepest essence, a grand and beautiful mystery waiting to be solved. Section 10. The Unseen Within and a Universe of Wonder. And so, our long journey through the unseen dimensions of reality is drawing to a close. We have traveled from a simple point to the intricate six-dimensional folds of a Calabi-Yau manifold. We have pictured our universe as a shadow, a slice, a membrane floating in a vaster whole. We have imagined all of reality as a symphony of vibrating strings. These are the grandest ideas that the human mind has yet conceived to describe the cosmos. As we bring our exploration to a gentle end, let's not focus on the complex physics, but on what these ideas mean for us. What is the human meaning of a higher dimensional universe? Firstly, it is a lesson in humility. Our senses, which we rely on so completely, show us a world of 3 dimensions. It feels absolute. It feels complete. But we have learned tonight that our perception might be profoundly limited. We may be like the Flatlander, confident in our 2-dimensional world, completely unaware of the glorious 3rd dimension of up that surrounds us. This idea invites us to hold our certainties a little more lightly. It suggests that there are truths about reality that are not just unknown, but currently unknowable to our direct senses. It encourages a state of open-mindedness, of wonder, of accepting that the map is not the territory. The reality we experience is not necessarily the entirety of reality itself. Secondly, it is an invitation to see the universe as a place of infinite richness and beauty. The idea that every point in space contains a hidden, complex geometry, that the laws of nature flow from the shape of these unseen dimensions. This transforms the universe from a collection of inert matter and empty space into a work of sublime, intricate art. It suggests a hidden layer of reality, a deeper order and elegance that underpins everything we see. The world becomes more magical, more mysterious, and more alive with possibility. The mundane becomes profound. The empty space in your room is not empty. It is teeming with the potential of curled-up dimensions and vibrating strings. And finally, it is a source of deep and abiding peace. The idea of the block universe, where all of time exists at once, can free us from the tyranny of the fleeting moment. It tells us that our most cherished memories are not gone, but are a permanent part of the universe's structure. The concept of the multiverse, of countless other brain worlds, can make our own problems and anxieties feel smaller in the grand cosmic scheme. It connects us to a reality so vast and so ancient that our own brief existence becomes not a source of fear, but a precious and unique opportunity to witness a tiny fraction of its splendor. The questions we have asked tonight: are we the shadows on the wall? Is time a frozen landscape? Is our universe just one brain among many? These are not questions to be answered before you can sleep. They are questions to be slept on. They are seeds of wonder to be planted in the fertile ground of your subconscious mind. Let them grow into dreams of cosmic scale. There is nothing left to do now. You have journeyed far. You have expanded the boundaries of your mind and touched upon the edges of reality. Now it is time to let go. Let go of the tesseract. Let go of the vibrating strings. Let go of the curled-up dimensions. Let these vast ideas dissolve into a simple feeling of peace, a feeling of being a small but meaningful part of a universe that is more grand, more beautiful, and more mysterious than you can ever fully know. Feel the gentle pull of sleep. It is a journey into another unseen reality, the world of your own inner space. Allow yourself to drift now on the quiet cosmic currents you have been exploring. Trust that you are safe. Trust that you are part of this magnificent, multi-dimensional cosmos, and allow yourself to plunge into the deep, restorative, and peaceful ocean of sleep. Drift now, let go, and sleep well. Section 11. The Holographic Principle. A universe on a surface. Let us drift now to a new shore of thought, a concept so profound and so counterintuitive it feels like it belongs in a dream. Yet it arises from the deepest and most rigorous investigations into the nature of black holes and the laws of information. It is called the holographic principle. Let the words themselves be a gentle mantra. Holographic principle. You may be familiar with a hologram, a flat 2-dimensional piece of film that, when illuminated by a laser, produces a stunningly complete three-dimensional image. You can walk around the image, see it from different angles. All the information required to create that rich 3D world is somehow encoded onto the 2D surface of the film. Now, take a slow, deep breath. And as you exhale, imagine expanding this idea to the entire universe. The holographic principle suggests that our universe, this seemingly vast three-dimensional reality that you are experiencing right now, might be a projection. It suggests that all the information that makes up everything you have ever known, your body, this bed, the planet Earth, the farthest galaxy, is not stored within the volume of space itself. Instead, it is all encoded on a distant two-dimensional surface that marks the boundary of our cosmos, the screen upon which our 3D reality is projected. This idea did not come from idle speculation. It emerged from a deep puzzle concerning black holes. When an object falls into a black hole, its information seems to be lost forever, a violation of the laws of quantum mechanics which state that information can never be destroyed. But physicists Jacob Bekenstein and Stephen Hawking discovered something remarkable. They found that the amount of information a black hole can contain is not proportional to its three-dimensional volume, as one might expect. Instead, it is proportional to the two-dimensional area of its event horizon, its surface of no return. It was as if the black hole was storing all the information of the three-dimensional things it had swallowed on its two-dimensional surface. The 3D interior was, in a sense, a projection of the information held on its 2D boundary. The holographic principle takes this strange property of black holes and applies it to the universe as a whole. The boundary of our observable universe is a surface, a cosmic horizon beyond which we cannot see. The principle proposes that this cosmic surface acts like the event horizon of a black hole, or like the holographic film. Everything happening inside the universe, within the bulk of 3D space, is a holographic projection of physical processes and information written on that two-dimensional boundary. What does this feel like to contemplate? It suggests that the third dimension, the dimension of depth that feels so real to us, might be an illusion. A very convincing, very consistent illusion, but an illusion nonetheless. It suggests that space itself might not be fundamental. The true reality would be a flatter, more exotic world of quantum fields dancing on the edge of space-time, and we are merely the grand, three-dimensional hologram they project. Think of the pixels on a screen. They are arranged on a two-dimensional grid, but they can create an image of breathtaking depth and complexity. The holographic principle suggests that the universe has a fundamental pixel size, an ultimate resolution, known as the Planck length. If you could zoom in to this impossibly small scale, you might find that our smooth, continuous 3D space dissolves into a discrete, grainy structure, like the pixels on a screen, revealing the underlying 2D nature of reality. So, we must ask ourselves a gentle, mind-bending question. Are we living in a hologram? Is your sense of depth, the feeling of moving through a three-dimensional room, a product of a more fundamental two-dimensional physics happening on a surface at the edge of time? This doesn't mean the world isn't real. The hologram is real. The pain and the joy you feel are real, but the description of that reality, its fundamental nature, might be radically different from how we perceive it. It is like listening to a beautiful piece of music. Your experience is one of emotion, melody, and harmony. But the fundamental description is one of vibrations in the air, or ones and zeros on a digital file. Both are true. One is the experience. The other is the code. The holographic principle suggests our 3D experience is the music, and the 2D boundary is the code from which it is played. Let this thought gently dissolve your sense of solidity. Feel the world around you not as a collection of solid objects, but as a complex, information-rich projection. A shimmering cosmic light show of immense scale. There is a strange lightness to this thought, is there not? A sense that the universe is less like a machine made of hard parts and more like a thought being thought. An idea being projected. As you drift off to sleep, imagine you are floating within this grand hologram. Let the illusion of solidity fade away, and just be with the pure information, the pure light, the pure vibration that constitutes the true nature of your holographic reality. There is nothing to hold on to. You can simply float peacefully within the cosmic projection. Section 12. Singularities and wormholes, gateways in space-time. Our journey has taken us to the very small, to the curled-up dimensions, and to the very fabric of reality itself. Now let us guide our minds to the very extreme, to places in the cosmos where our understanding of space and time is stretched to its breaking point and then shatters. Let us journey, in our thoughts, to a singularity. A singularity is a prediction of Einstein's general relativity. It is a point of infinite density, infinite gravity, and infinite curvature of space-time. It is a place where the laws of physics as we know them cease to function. General relativity tells us that at the center of every black hole, there lies a singularity. And in the past, at the very beginning of the universe, there was the singularity of the Big Bang. Imagine all the matter of a giant collapsed star crushed down into a space smaller than an atom. Infinitely small. The gravitational pull becomes infinite. Time, for an object reaching the singularity, would come to a stop. It is a boundary, an edge to space-time itself. But what is it really? Physics abhors infinities. They are usually a sign that a theory is incomplete, that it is missing a piece of the puzzle. This is where our journey into higher dimensions becomes not just a mathematical game, but a potential solution. Theories like M-theory suggest that at the extreme energies and densities of a singularity, the true, higher dimensional nature of reality would reveal itself. Perhaps a singularity is not an infinitely small point in 3 dimensions. Perhaps it is a place where our 3-brain universe is punctured or torn. A place where the immense energy has opened a gateway, a throat, into the higher dimensional bulk that we have spoken of. This leads us to one of the most tantalizing ideas in all of physics, a wormhole. Also known as an Einstein-Rosen bridge, the mathematics of general relativity allows for the existence of these structures. A wormhole is a theoretical shortcut through space-time. Imagine space-time as a sheet of paper. To get from one point to another, you would normally travel across the surface of the paper. But what if you could bend the paper, bringing the 2 points close together, and then punch a hole through the paper, creating a tunnel? That tunnel, that shortcut, is a wormhole. Crucially, this tunnel does not exist within the 2 dimensions of the paper's surface. It passes through the 3rd dimension, the space above and below the paper. In the same way, a wormhole in our universe would be a tunnel through the higher dimensional bulk. It would connect 2 distant points in our own universe. Or perhaps it could connect our universe to another. Gateway between brain worlds. Could a black hole be one end of a wormhole? The idea is captivating. You fall into a black hole, and instead of being crushed into a singularity, you pass through a tunnel in hyperspace and emerge somewhere else entirely. Perhaps in another galaxy, perhaps in another universe. The other end of this wormhole, where things emerge, is sometimes called a white hole, a theoretical object that spews matter and energy out, but which nothing can enter. As a sleep-inducing thought, this transforms the terrifying image of a black hole into something far more mysterious and wondrous. It is no longer just a cosmic abyss. It could be a doorway, a place of transformation, a cosmic transportation system operating on principles of geometry we are only just beginning to grasp. Now, physics tells us that any wormhole we could imagine would likely be incredibly unstable. It would collapse in on itself the instant it formed, before anything, even light, could pass through it. To hold it open would require a form of exotic matter with negative energy or negative pressure, something we have never observed and are not sure can exist. But let us not be constrained by these practicalities tonight. Let us simply dwell on the possibility, on the geometric beauty of the idea, that the fabric of our reality might be folded and connected in these incredible, hidden ways. That there could be secret passages woven into the cosmos. What does it feel like to imagine our universe is not a simple, continuous expanse, but a complex tapestry with hidden tunnels and secret connections? Does it make the universe feel more interconnected, more full of secrets? Think of the Big Bang singularity. We think of it as the beginning of everything. But what if it was not a beginning from nothing? What if the Big Bang was the white hole end of a wormhole, spewing out matter and energy that had fallen into a black hole in a parent universe? Our entire cosmos, in this view, could be the child of another, older universe, connected by a transcendental umbilical wormhole. Let your mind drift on these ideas. They are at the very edge of our knowledge, where science, philosophy, and imagination meet. Do not try to solve the paradoxes. Simply appreciate the shapes. The shape of a tunnel through hyperspace, the shape of a universe born from another, the idea that the most violent and extreme places in the cosmos might also be the most transformative, the places where the veil between dimensions is at its thinnest. Rest in the knowledge that the universe is filled with such deep and profound geometric possibilities. Section 13. The Arrow of Time and the River of Entropy. We have visited the idea of the block universe, where time is a static fourth dimension, and all of history exists at once. This is a deeply calming and peaceful concept, yet it sits in stark contrast to our most fundamental experience. We do not experience time as a static landscape. We experience it as a flow, a relentless one-way river, carrying us from a fixed past, through a fleeting present into an open future. Why this discrepancy? Why does time have an arrow? The answer, as best as physics can provide, lies not in the nature of time itself, but in a property of the universe called entropy. Let's explore this concept, not as a complex law, but as a gentle, unfolding story. Entropy is, in simple terms, a measure of disorder or randomness. The second law of thermodynamics, one of the most fundamental laws in all of physics, states that the total entropy of a closed system, like our universe, will always increase over time. Things tend to move from a state of order to a state of disorder. Think of a sandcastle on a beach. It is a highly ordered structure. The wind and the waves will inevitably break it down, scattering the grains of sand randomly across the beach. The sandcastle will not spontaneously reassemble itself. An egg, when dropped, shatters into a disordered mess. You will never see the mess of yolk and shell gather itself back into a perfect, unbroken egg. A drop of ink in a glass of water starts as an ordered, concentrated blob, but it will spread out, diffusing until the water is a uniform, disordered gray. This one-way process, this inevitable march from order to disorder, is what gives time its direction. The past is simply the direction of lower entropy. The future is the direction of higher entropy. The reason we can remember the past but not the future is because the past contains states of lower entropy, of more order, from which the present evolved. We can't remember the future because it hasn't settled into a state yet. It is a sea of high entropy possibilities. So the arrow of time we experience is, in essence, the arrow of entropy. But this raises a much deeper question. If the universe is constantly moving towards a state of greater disorder, this must mean that it began in a state of incredible, breathtaking order. And indeed, it did. The Big Bang, for all its heat and chaos, was a state of extraordinarily low entropy. The initial conditions of our universe were highly ordered, like a perfectly wound-up clock, and for the last 13.8 billion years, that clock has been unwinding, its energy spreading out, its structures forming and decaying, its entropy constantly increasing. The entire story of the cosmos, from the formation of galaxies to the evolution of life, is a temporary flowering of complexity on the inexorable river of rising entropy. What does this mean for our journey into higher dimensions? It connects the block universe to our lived experience. Within the static four-dimensional block of space-time, there is a gradient. A smooth progression from one end of the block, the low-entropy Big Bang, to the other, a high-entropy future. Our consciousness, our minds, are processes that rely on this increase in entropy. We take in ordered information, process it, and generate disordered heat. Our very thoughts are part of this entropic flow. So, the feeling of time passing is the feeling of your own consciousness riding this cosmic wave of increasing disorder. You are not a passive observer of the river. Your existence is part of the river's current. As you lie here on the edge of sleep, feel this connection. Your breathing, the warmth of your body, the gentle fading of your thoughts, these are all processes that contribute, in their own infinitesimal way, to the universe's great unwinding. There is a deep peace in surrendering to this flow. It is the most natural thing in the universe. It is the direction of reality itself. Does this mean the future is bleak? A descent into a final, featureless heat death of maximum entropy? Perhaps. But along the way, this process creates pockets of immense beauty and complexity. Stars a temporary island of order. A living organism is a breathtakingly complex structure that maintains its order by increasing the disorder around it. You are one such structure. A fleeting, beautiful, highly ordered pattern in the grand cosmic story of entropy's rise. So let go of the struggle against time. Let go of the feeling of being rushed. You are simply flowing with the universe's most fundamental current. The past is not a place of regret. It was a more orderly state. The future is not a source of anxiety. It is a realm of higher probability. There is only the gentle, continuous process of becoming. Let the river of entropy carry you now into the quiet, disordered peace of sleep. Let your own ordered thoughts diffuse and fade, joining the great, silent, cosmic flow. Section 14. The Anthropic Principle and the Landscape of Worlds. Let us gently return to the string theory landscape, that vast, perhaps infinite collection of possible universes, each corresponding to a different shape for the hidden dimensions, each with its own unique laws of physics. We pictured it as a landscape with 10 to the power of 500 valleys, each one a different, stable reality. This idea is staggering, but it can also feel disconnecting. If there are so many possible worlds, what makes our universe special? Why are we here, in this particular valley with this particular set of rules? This question brings us to a concept that is both powerful and controversial, a philosophical lens through which to view the cosmos. It is called the Anthropic Principle. In its simplest form, it states that our observations of the universe are inevitably biased by the fact that we are here to observe it. This sounds like a simple truism, but it has profound implications. Think about the fundamental constants of nature, the strength of gravity, the charge of an electron, the speed of light. Physicists have found that if these values were even slightly different, the universe as we know it could not exist. For instance, if the strong nuclear force that binds atomic nuclei together were just a few % weaker, then hydrogen would be the only element in the universe. No carbon, no oxygen, no stars, no planets, no life. If it were slightly stronger, all the hydrogen would have fused into heavier elements in the first few minutes of the Big Bang, leaving no fuel for long-lived stars like our sun. Our existence seems to balance on a knife's edge of cosmic coincidences. This is known as the fine-tuning problem. Why is our universe so exquisitely fine-tuned for the existence of life? One answer could be that it was simply designed that way by a creator. This is a valid philosophical and theological position, but it lies outside the realm of what science can test. Another answer is pure chance. We just got incredibly astronomically lucky. But the string theory landscape, combined with the anthropic principle, offers a third, more scientific possibility. If there is a multiverse, an immense landscape of other universes with different physical laws, then it is no longer a surprise that we find ourselves in one that is hospitable to life. It is a matter of selection bias. Imagine you are a fish, and you find yourself wondering why your entire world is made of water. Is it an incredible coincidence that you happen to live in the one substance that allows you to breathe and swim? Of course not. You are a fish. Therefore, you are guaranteed to find yourself in water. You could not exist anywhere else to ask the question. Similarly, we conscious observers are guaranteed to find ourselves in a universe whose laws allow for conscious observers to evolve. In all the other universes in the landscape, the ones where stars never formed, or where gravity is a repulsive force, or where chemistry is impossible, there is no one to wonder about it. Those universes are sterile and silent. The only universes that are observed are the ones capable of producing observers. So the anthropic principle suggests that the fine-tuning of our universe is not a coincidence that needs explaining. It is a prerequisite for our own existence. We are here because we are here. Does this feel like a satisfying explanation, or does it feel like a circular argument? Let your mind hold the question gently. It is a profound shift in perspective. It suggests that our existence is not an accident in a single fixed universe, but an inevitability in a vast multiverse of possibilities. This idea connects the grandest scales of cosmology with the intimate fact of our own consciousness. The shape of the hidden Calabi-Yau dimensions in our corner of the multiverse is not random. It is one of the rare shapes that allows for the string vibrations that create a chemistry rich enough for life. We are, in a very real sense, a product of a hidden six-dimensional geometry. As you lie here, feel the preciousness of this particular reality. Out of a near infinity of possible worlds, this is the one we get to experience. This is the valley in the landscape where the conditions were just right. The air you are breathing, the stable matter of your body, the quiet laws of physics that hold your world together, these are all a consequence of our universe's specific location in the grander landscape. There is a deep gratitude in this thought, isn't there? A sense of wonder, not just at the universe, but at the sheer fact of our ability to witness it. We are the universe's way of knowing itself, born in one of the few fertile gardens in a vast, multi-dimensional cosmos. Let this thought comfort you. Your existence is not a meaningless blip. It is a confirmation of the life-giving properties of this specific set of physical laws. Rest now in this fine-tuned, life-giving, and exquisitely beautiful universe. Section 15, our brain. A three-dimensional filter so far, our journey has been outward, into the structure of space, time, and the cosmos. For this section, let us turn our gaze inward. Let's consider the instrument that is perceiving all of this, the human brain. We have been asking what reality is, but now let's ask a gentler question. How much of reality are we built to perceive? Your brain is a three-dimensional object of astonishing complexity. It evolved over millions of years, not to contemplate 11-dimensional M-theory, but for much more practical purposes, to find food, to recognize patterns, to avoid danger, to navigate a three-dimensional environment. It is a survival machine, and it constructs a model of reality that is useful for that purpose. But is that model the whole story? What if reality is a vast, high-dimensional flood of information, and the brain acts not as a generator of consciousness, but as a filter, a reducing valve? Its job is to block out the overwhelming majority of reality that is irrelevant to our survival, and to let through only a tiny, trickling stream of information that we can process and act upon. Think of a radio. The air around you is filled with countless radio waves, carrying different stations, different music, different conversations. But the radio is not a chaotic mess of sound. It has a tuner. It is designed to select one specific frequency and filter out all the others, allowing you to hear one clear station. Perhaps our consciousness is like that. Perhaps our brain is a biological tuner, evolved to be locked onto the frequency of 3 spatial dimensions and 1 dimension of forward-flowing time, because that is the station where survival happens. The other dimensions, the other realities, the curled-up Calabi-Yau spaces, the higher dimensional bulk, the other brains, could be all around us, like those other radio stations, but our brains simply are not tuned to perceive them. This is a speculative idea, of course, on the very edge where neuroscience meets philosophy. But it is a powerful one for our quiet contemplation. It suggests that what we call reality is a carefully curated sliver of a much larger, multi-dimensional whole. What might be some hints of this? Think of moments when that filter might be temporarily relaxed. In dreams, the rigid laws of 3D space and linear time often dissolve. We can fly, be in 2 places at once, experience events out of sequence. Could dreams be a fleeting glimpse into a more fluid, less filtered state of consciousness, where the constraints of our 3D tuner are loosened? Think of moments of deep meditation, or profound artistic or spiritual insight, where individuals report a sense of timelessness, of unity with the cosmos, a feeling that the boundaries of the self have dissolved. Could these be subjective experiences of the brain's filter becoming more permeable, allowing a brief connection to a more holistic, less differentiated reality? We are asking these questions not to find answers, but to open our minds. The idea of the brain as a filter changes our relationship with our own perception. It means that the limits of what we see are not necessarily the limits of what is there. Could it be that the very structure of our thoughts, the subject-object duality of our language, is an artifact of this 3D filter? Perhaps in a higher dimensional state of being, the distinction between observer and observed, between self and universe, would cease to have meaning. As you lie here, becoming more and more relaxed, feel the presence of your own mind, not as a busy, chattering narrator, but as a quiet, receptive instrument. Feel the filter at work, constructing this stable, predictable reality of the room around you. And then, just for a moment, imagine that filter gently, softly, becoming more transparent. Imagine you could sense, not with your eyes or ears, but with your whole being, the tiny, curled-up dimensions at every point in space. Imagine you could feel the presence of the block universe, your past and future, existing as a unified whole. Imagine you could perceive the gentle gravitational hum from a parallel universe, just a fraction of an inch away, in the fourth dimension. You don't need to see these things. Just hold the possibility. This transforms your mind from being a prisoner in a three-dimensional cell to being a resident in a single familiar room of a vast, multi-dimensional mansion. There are other rooms, other realities, that you may not be able to enter, but their presence makes your own room feel connected to something much, much larger. Let this thought be a final comfort as you prepare for sleep. Your consciousness is your unique window onto the cosmos. It may be a small window, but it looks out upon an infinite landscape. And perhaps in the quiet stillness of deep sleep, the window opens just a little wider. Section 16. The end of space-time. A final gentle question. Our grand tour is almost complete. We have journeyed across dimensions, through brains, and into the very nature of time and mind. There is one last place to visit in our imagination, a place where the very concept of dimension, the bedrock of our entire journey, may itself dissolve. Let us journey to the Planck scale, the smallest possible scale of reality. We have spoken of the Planck length, a distance so unimaginably small that it is to an atom what an atom is to the entire observable universe. At this fundamental level, physicists believe that our classical picture of a smooth, continuous spacetime breaks down completely. General relativity and quantum mechanics, in their final, ultimate clash, tear the fabric of reality apart. Welcome to the quantum foam. Imagine the surface of the ocean. From high above, it looks smooth and flat, but as you get closer, you see waves. Closer still, you see ripples and chop, and at the smallest scale, you see a chaotic, bubbling, foaming turbulence. Spacetime at the Planck scale is thought to be like this. It is not a calm geometric grid. It is a roiling, chaotic foam of quantum fluctuations. Tiny, virtual wormholes may be constantly popping into and out of existence. Dimensions may be created and destroyed in an instant. The very idea of a stable number of dimensions, 3 or 10 or 11, might lose its meaning in this realm. What is reality like here? What is the fundamental substance that is foaming and bubbling? We do not know. This is the absolute frontier of knowledge. Some physicists believe that space and time are not fundamental at all. They are emergent properties. What does it mean for something to be emergent? Think of temperature. A single atom does not have a temperature. Temperature is an emergent property of the collective motion of many atoms. It is a statistical macroscopic idea. Similarly, think of wetness. A single molecule of H2O is not wet. Wetness is an emergent property of a large collection of H2O molecules. Perhaps space and dimension are like this. Perhaps at the most fundamental level, there is no space. There are no dimensions. There is only some kind of pure information, some form of quantum interconnectedness, governed by a set of rules we have yet to discover. And from the collective behavior of this fundamental information, our familiar world of 3 spatial dimensions and 1 time dimension emerges, just as temperature emerges from the motion of atoms. This is the deepest and most profound possibility of all, that the stage upon which our universe plays out is not the ultimate reality. The stage itself is an illusion, an emergent phenomenon. The real action is happening at a deeper level, a level without space, without time, without dimension as we know it. A pre-geometric reality. As you lie here on the very edge of sleep, let this final idea wash over you. It is the ultimate letting go. We let go of our attachment to 3 dimensions. We let go of the idea of 10 or 11 dimensions. We even let go of the idea of dimension itself. We are left with a final, gentle question, a question to carry with you into the silence of sleep. What is it that remains when space and time have dissolved? There is no answer. There is only the quiet, peaceful, humbling mystery, a mystery that lies at the heart of existence. You have explored the unseen reality that may be hiding all around you. You have allowed your mind to expand, to touch the infinite, to ponder the impossible. You have been a magnificent traveler. Now the journey is over. It is time for a deep and well-earned rest. Let all these ideas, the holograms, the wormholes, the brains, the foam, let them all merge and dissolve into a single feeling of profound wonder. You are a conscious part of a universe that is deeper, stranger, and more beautiful than any story ever told. There is nothing more to think about. There is nothing more to explore tonight. There is only the soft darkness, the gentle rhythm of your own breathing, and the vast, silent, and peaceful mystery of it all. Sleep now. Sleep deeply. And dream of everything and of nothing at all.